So the setup for freezing bromine is similar to the setup I used for freezing xenon and chlorine. I've got a bromine vial in another glass vial with a stopper there, and then this will be put in there. The copper evens out the cooling. The first glass vial slows down the cooling, which together with the copper increases the probability that nothing will break. And then this stopper here stops moist air from getting in and making ice blocking our view in a way that can't be cleaned off easily. We'll put liquid nitrogen in there and do this in a fume hood. In goes the liquid nitrogen. Now we can set the bromine in. I can do it slowly because it will boil vigorously. It'll start cooling off. I think the liquid nitrogen boiling is kind of mesmerizing. Okay, it should be frozen now. Whoops. Come on, I just took the top off. Just let a bunch of moist air in. Whoa, whoa, look at that. Solid bromine. Check that out.
It's red.
Yeah, it's not focusing very well. Let's see if I can zoom in and get it to focus better. Oh wow, okay, there we go. That's a better shot. Yeah. That is weird and red. I want to catch it melting. So that's the thing I'm most interested in seeing. Oh, I think it's already started to melt. Let's see if we can just get the vial out. Pull the cork out. Okay, so it's already started melting, definitely, and coating over. Probably melt more slowly, but it's still mostly, or at least largely solid, because it's not really started flowing around very well. Whoa, wait, look at that, it's starting to, the ice is starting to melt, interestingly. I guess it must be. Let's see if that melts enough for it to be visible after all. Wow, that's absorbing quite a lot of heat, the bromine. It's staying cold right where the bromine is. Oh, look, liquid bromine starting to flow off. You can't see the solid, but look, it's melting. Oh, wow. Way cool. And look, the ice is starting to melt. Wow. It's still melting. There's still bromine ice in there. You can see the level isn't quite flat. And it's still icy because the bromine's still absorbing heat as it melts. Oh, cool. Look, there's still a bit of bromine ice in there. I pulled the liquid away. Whoa. Okay. So now you can't see the remaining chunk of bromine ice, assuming there is any. Okay, so the problem we had last time was that the glass didn't contract as much as the rubber, and so the rubber stopper just came out really easily and let a bunch of moist air in. So what I've got here is an earplug jammed in there in front of the cork, so that if the cork comes out again, we can still have a reasonable chance at not getting too much moist air in there. This will allow us to film the bromine for hopefully longer without it icing up. Now, of course, we could just take the vial out and wipe it down directly, but it's kind of small, and thermal shocking it is something we want to avoid because we don't want to lose the sample. This outer vial we definitely know can stand that. It's just more likely to yield a good result to do it this way. Also, we need this outer vial for the cooling process. So just pull this out. Ooh, the earplug totally worked. Look at that solid bromine. There we go. Okay, now you can see bromine. It's bromine slush at the moment, but it's still stuck up there. Guess it's not quite flowy enough to be slush. Yeah, so the earplug also contracted and let moist air in. So the solid bromine, as you saw from what clips I could get of it, it's kind of a red color, a light red color. Much lighter than the liquid. But then as soon as it starts to melt, even if it's still frozen enough to not flow very well, it does go dark just because there's liquid present. Let's see, what kind of liquid is in there? Just a little drop. Oh yes, you can see it's starting to flow more. There's another droplet. It's not really condensing so much on the outside anymore. Ooh, another droplet. Melting off the solid. Very cool. Oop, another one. It's melting faster now. There goes another. This is like an hourglass almost. Latent heat of solid bromine controlled hourglass. That's the liquid that's come over so far. There's some more. Oh, the big chunk of solid came over. You can see now it's at the other end. The solid's at the other end. Oh, not. Oh, the solid's sliding around. Bromine ice. See that chunk that sticks behind a little bit? That's still the solid. This is really interesting. Well, I guess beyond this is basically the same as last time. So I'm trying a new type of plug, one that I hope won't contract so much. It's aluminum foil that's bunched up with electrical tape on it. I really hope that this seals well. I want to get a better picture of solid bromine. Got a better camera mount situation now, so I can feasibly keep the condensation off the outside of the vial better. We'll see how that goes. I'm going to try to film the solid bromine below the plume of nitrogen. It's in here. So the condensation can't form. Okay, I did manage to get it out, and there wasn't too much condensation on it, but it was partially melted, so I'm re-cooling it. That's what solid bromine looks like. That may be the best shot yet of the solid. Still cryo pumping air. Solid bromine is really solidly frozen bromine. I poured nitrogen in the vial there. After seeing this video, you can no longer claim that you don't know what solid bromine looks like. These are the kinds of services I provide. If you like this video, please give it a thumbs up, and don't forget to subscribe. Dietterich out.